and I am studying in 9th standard D section. So today I have an interesting topic, that is maths, the invisible hero. Yeah guys, maths is all around us, not only in just paper, it is everywhere around us. Come on, let's see how it is applicable in everyday life. Okay, before proceeding, I'll just ask you something. Will you believe it that the maps which we are using, the world maps, are fake? Yeah guys, it is fake. Why? Because in real life and in scientifically, China is 4.4 times larger than Greenland. But in maps, when we see Greenland and China, both are almost in equal size. Why is it so? Come on, let's understand this by a remarkable theorem. Yeah guys, this theorem was given by the mathematician called Gauss. He is a German mathematician and he is also called as the Prince of Mathematics. Okay, what is remarkable theorem? To observe that, we will see an example. So this is a flat surface. Now to find the curvature of this surface, I have to consider it both vertically and horizontally. Vertically it is 0 curvature and horizontally 0 curvature. So 0 into 0, 0 curvature. So this total flat surface curvature is 0. Now you may ask, when I roll this paper into the cylindrical shape, then the curvature changes, right? Yeah, it changes only in horizontally. But what about vertically? It still stays 0. So that positive into 0, again you will get 0 curvature. That's why the remarkable theorem states that when we bend an object, its curvature will not change. When it is as it is 0 curvature. Even when I bend it, it is also 0 curvature. That's what remarkable theorem states. Okay, we'll see how it is applicable in maps. Now when you take a globe, an actual sphere, you can see that China is larger than Greenland. But why it is equal in size, or sometimes Greenland is larger than China in maps alone? Because we can't turn a sphere or curved surface directly into flat surface. Another one example will be when I take a gift wrapper and a ball, when I try to cover it, I can't wrap it properly because it has some mismatches. Because a flat surface cannot be a curved surface, a curved surface cannot be this flat surface. That is the reason behind this. That's why when they are converting the sphere into the flat surface, they used to enlarge the sizes of top and bottom area so that Greenland is enlarged compared to China. That's why in maps we have both the sizes to be equal, or else sometimes in some maps Greenland is to be larger than China. Okay, now we'll see some other examples for curved figures, which is in our day-to-day life. When you take a pizza for eating, always the pizza would fall due to some cheesiness. But you will use a small trick. You will bend the cheese, bend the pizza, and you will eat, so that it would be proper for you to eat. Here, a small curve shape is formed. This curve shape is called as parabola. And what is parabola? We'll just see. Parabola is a type of conic section. We have 4 types of conic sections. First is circle, next one ellipse, next parabola, then hyperbola. We have lots of examples for parabola and hyperbola, such as cardboard. Inside cardboard we have lots of parabola figures and sheets. Guitar, it is an example for hyperbola. Then shutter. Even in studio rooms we have a light stand. This also comes under parabola. And concave lens, which is used in telescopes and binoculars, is also comes under hyperbola, as it is bent inwards both the sides. Then sand clock, hyperbola. Then we use more hyperbola and parabola in construction purpose, because these curved figures will be leading to a strongest figure, so that it would be a great basement. We use this in Eiffel Tower. Then Dallas Airport, here we use a parabola shape as a roof. Then in San Francisco we have Bay Bridge. Then Bixby Creek Bridge. Then even roller coasters. And in Chennai we have Napier Bridge, which is also made by parabolic arc. So here this parabolic arc is not only used as a design, it is a major concept which is used for keeping the bridge very strong. Next we have the Coke Port. power plant which is made up of hyperbola. So why do we use all these curved figures? Because to make it stronger than the usual. Even if any natural disasters get affected in that area, with these structures we can avoid some more damages. But there will be damages, we can avoid more damages. So by this I conclude that maths is the invisible hero. It stays everywhere and every moment, single thing it stays, but we don't know. It is just this topic is just a part in mathematics. Still we have lots of theorems and lots of number theories. We will not have enough time to learn all those things, but still maths is everywhere and it stays as an invisible hero. Thank you.
Good afternoon to everyone. Myself V. Logaroshni. Myself T. Jayapriya. We are from grade 9G. Today we are here to explain our topic on the concept of parabola. Generally, what is a parabola? A parabola is actually a U-shaped figure which has all the points equidistant from a point called focus and a line called directrix. As you can see the figure, here this line means the directrix and this point on the parabola is said to be a focus. And in simple words, we can say a parabola as a line which is equidistant from a point and a line. And you may have a doubt that whether all the shapes comes under parabola. There are many shapes such as ellipses, circles and the figures drawn using freehand. Do they all come under parabola? Absolutely no, because parabola follows some unique properties. Some of the properties are, first and foremost thing is the reflective property of the parabola, which plays an important role in many other applications in our real life. And the second property is the directrix property, which means that the point on the parabola is always equidistant to a point to the focus and the line to the directrix. To depict our model, we are having three applications. The first one is the satellite model, the second one is the passing parabola, and the third one is the parabolic bridge. So now I will be explaining about the passing parabola. A straight bar passing parabola is a model used to demonstrate how a straight bar can pass through a parabola. It is typically used in physics to illustrate how a straight bar is manipulated to pass through a parabola. It is used to show how the shape of parabola is obtained by manipulating the orientation of the bar. It is used to show the curvature, how the curvature of the parabola is changed by the orientation of the bar. It is being used in science parks and educational institutions. The mathematical concept behind the parabola are the quadratic equation. The parabola is the graph of x equal to ay square plus by plus c. And the parabola is symmetrical about its axis and it is equally balanced on the both sides. The turning point where the parabola changes the direction is called the vertex. So now you can see that this bar is little lengther than this curve. So it goes inside and comes due to the curvature of the parabola. So in this graph, the line passing through this curve is called the tangent. And the next application on the parabola is the parabolic satellite model. So in this application, it is a simple model to explain the principle of light using a parabolic shaped surface. Here the satellite dish is used as the parabolic surface and many other places use as the dish in the parabolic surface only. By this model, you will understand answer for the question that why these dishes are the shape of a parabola. And here we are having a satellite with a light which is inserted with a light source and having a power supply. When the light source is switched on, the rays emitted by the power supply get hits in the reflective surface and get reflected back according to the laws of reflection. Here you maybe have the doubt, why does laws of reflection comes here? It is a concept involved in physics, but here you need to understand the point that here it follows a geometric rule that always angle of incidence is equal to the angle of reflection. And by this model we can depict many other real life examples in our world. Such examples are headlights, solar concentrators, flashlights, torches, etc.
Good afternoon, I am Basmati, there my team is Sudisha and Srileka. Today we are going to explain about the ellipse. What do you mean by ellipse? In a cone, when we slice with the some particles, it is known as ellipse. For example, take a glass with water. When you what shape would you get? Circle, right? When you tilt the glass, you could get ellipse. This is the formation of ellipse. Now Sriksha will explain about this.
Ellipse has two focus points. If I take this laser and keep it on one focus point, it will hit on the mirror and come back to the second focus point. So I'm keeping it over here and it comes over here. I'm keeping my hand over here and you can see the red light coming through here. Same like this, if you keep it, the laser point anywhere and will hit the mirror and come back to the second focus point. Where do we find ellipse?
Solar system.
In lithotherapy and whispering wall. Whispering wall is situated in St. Paul's Cathedral, which is in London, UK. This is the whispering wall. If you are standing over here, this is the focus point 1. You are saying something, the person on the second focus point will be able to hear it. But if the person is not standing on the second focus point, the person will not be able to hear it.
This image shows lithotherapy. This sound emits the ultrasonic wave and it hits in the elliptical reflector and it hits to the second focus point where the stone has been present. Now the ultrasonic waves breaks the stone into pieces and removes the kidney stone. This is how elliptical concept is used in medical industries. And now we will see about elliptical training equipment. This can be seen in gyms and this equipment is very beneficial. Some benefits are it burns calories,
It reduces stress.
And it increases muscle strength.
and it is very good for our heart. In a nutshell, this equipment is very beneficial and ellipse is an advanced shape can be used in every applications. Thank you.
Good morning. Today our topic is about differentiation. Today we gonna discuss about the real life application of differentiation, that is differential gear. First of all, we need to know what is differentiation is about. What is differentiation? It is discovered by Sir Isaac Newton. It tells about how a quantity is changing depending upon the change of another quantity. Example, change in displacement by change in time. That is nothing but velocity. So we are indirectly using the applications of differentiation in differential. First of all, we need to know what is the purpose of differential gear. Let me explain with a model. When a car is moving in a straight path, the power from the engine is given to the next two wheels with the help of differential, but it is equally distributed. So it is moving in a straight path. But when a car is in need of taking a turn, the situation is completely different. You can see here that the outer wheel have to take a longer distance. The trajectory of the wheel have to take a longer distance, whereas the inner wheel need to take a shorter distance. So it is only possible when these two wheels is spin in different speed. But we have only one engine to accommodate that. So that is why inventors invented differential gear to split the speed of the gear in differently inequally. He will explain you how the differential gear is working.
So there are 6 gears in the differential. The first gear is the pinion gear, which gets power directly from the engine. And this power gets transferred to the ring gear, which then spins both of the wheels at equal speed. And when one of the wheels slow down, the 4 extra gears, that are the spider gear and the sun gear, start to work. This spider gear spins around the sun gear, which helps it to accommodate 2 different speeds, that is lower speed and higher speed. This does not, differential topic does not exactly impact on this, but it indirectly impact on it, and it is also used in the manufacture of these gears. It's also used in rates of change of blood volumes and also ECG signals, and also in the business marginal cost.
Thank you.
Good morning, myself Hasni, I'm from grade 11. Today we are going to explain about building lifting concept. So good afternoon, myself Niteshi from grade 11. So this model is about lifting a building. So building lifting is nothing but lifting the existing building to prevent flooding and waterlogging. So we can lift it with 2 types, that is hydraulic lifting and using screw gauge lifting. So here we have used the screw lifting model. So hydraulic lifting is nothing but with the use of water and mechanical properties will lift, and screw lifting is nothing but manual technology. With the attachment of screw we will lift the buildings. So Madhya Vina's temple is lifted using this mechanism. So in Tamil Nadu about 25 to 30 temples have been lifted using this mechanism, but only Madhya Vina's the only temple which has been lifted as a whole temple. So, an important math concept plays a major role in this, nothing but of slope. So, in this screw, the slope concept is applied. When we rotate this screw, this model will be lifted. So, slope is nothing but of it used to measure the length and the direction of it. With the use of the measurement, we can lift the screw, lift the building. So, according to the weight of the model or building, we have to insert the screw. If the model, as this model, we have inserted 4 screws. If the model's weight is more now, we have to insert more screws to lift the building. So, in